Hello friends, welcome back to the bench. Thank you very much for joining me. Today we have a very interesting case of 2016 Subaru STI, and it's interesting for two reasons. So number one, what we have is 2016 STI that we are currently diagnosing. As discussed initially, came in with several secondary air faults and several aftermarket components. Once we replaced the secondary air components with all new OEM parts, we also found that the ECU was not grounding the pump as it should, and we were unable to perform the secondary air pump actuation. Upon testing, we found the ECU to be outputting around 3 volts for some reason. After we replaced it, everything worked, and it has been working for several months. But now the car is back again, and I have found the same issue with the ECU. So I asked, which pin are you measuring 3 volts on, right? And the pin is 27 on B136 connector. And here's another interesting thing. With those pinouts for the ECM, sometimes it get mixed up. So typically when I search for pinouts is by the year, but in 2016 you might have a model that was built in 2015, 2014, what have you, and released in 2016, but it's an earlier model, and vice versa. It's 2016, but the design is from 2017, and that is commonly found on 2017. So sometimes I will get the pinouts that are slightly off. Typically, the VCC, ground, CAN, ignition switch, they're usually the same. I have had one case where I was using 2006, I think, 2006 pinout, but the ECM actually was 2005, but the car was 2006. So that happens. So it might be the same case over here, that this is actually not 2016, it's 2015 or what have you. So we're gonna have the pinout from the customer, because this is from Simply Subarus. They do an awesome job, and they have access to much better sources of documentation than I do. I only have Google essentially. So we'll check that. But for now, let's follow the pin 27 on B136 connector. B13627, it's this pin. And our documentation says that B13627 is a starter switch to B13627. We see that it's an open emitter, not open collector. Which means if you're reading 3 volts over here, something is wrong, because you should be reading high over here, right? And since it's going to the starter relay, that's going to be, so it's not controlling the ground because we have a resistor to ground. So that's got to be an open emitter. So it would make sense that you're reading low over here and expecting high, but this is not for the air pump. It's for the starter relay. So what I did, I just found the starter relay, or the, what am I saying, the secondary air combination valve relay. We have 1 and 2 on B135.8 and B135.20, right? B135.8 over here, secondary air combination valve relay 1, and that is open collector. That's what we expect. So this is not turning on, and the second air combination valve relay 2 is also open collector. So these are not grounding, so they're unable to even command the ECM to turn on those transistors, so essentially ground those pumps, which means the ECM is unable to ground them, and that could be for two reasons. Number one, I wouldn't expect a short over here, but I would expect short on the outside, on the output or input. Actually, this is output, just, collector, open collector controlled. Technically, it's an output, but the current flows through the ECM to ground, right? Now, the ECMs, they don't use MOSFETs, they don't use field effect transistors, they use bipolar transistors. And with that, they are capable of measuring how much current is going into the transistor. And the current on the base is going to be proportional to the collector emitter current. So if the ECM detects that there's too much current going through, say there's short, it will not output, it will not ground it. So before we receive the pinout from Dave, let's go by this pinout and see what we can measure. If we have any weird readings on the ECM. So first, let's see B13620, what it shows to ground and to supply voltage. All right, supply rail. Oh, 27, not 20. 27. And we have a diode, essentially, a little higher voltage drop than the diode would give you, and we have some fluctuations. So this is open collector. And to voltage, we have 1.1. Let's see on this rail, 0.7, and here 2.6. This ground 0.6, this ground 0.6. Doesn't seem like there's anything obviously wrong here. Let's try and reverse. Oh, and we have the same reading in both directions. That is not right. Let's see the resistance. It's very rarely on any pin of the ECM, regardless whether it's open collector or open emitter. It's very rarely the same reading in both directions. We got 1.8 kilo ohms. If this is actually the starter switch or the starter relay. So let's go by this pinout first and see. Because 1.8, I was thinking that probably it's either open circuit, that's why it doesn't work, or we have a short. So I told Dave that, send it in, I'm just going to inject some voltage and see what's getting hot. Now in this case, since it's the same reading in both directions, that might be the problem, but as you can see, it's not a short. 1.8K, that's far from short. But we can still inject some voltage and see what's getting hot, and maybe we can find something. So let's try B135.8 and B135.20. We're in resistance, so let's keep it in resistance. So it is this pin, and we are open, and let's do the diode reading, but diode reading is going to be open line. Exactly. But in reverse, we should have a diode. And we have a diode in reverse. So the transistor is fine. So let's check 20. It's one below it. So in reverse, we want to see the diode. There you go. And in forward, we want to see open. And that's exactly what we're seeing. So if my pinout is correct, the transistors are good. So let's focus on the weird reading on 27, B13627. We're going to connect a little wire, and we're going to inject some voltage. No, not 12. Why do I keep saying 20? It's 27. B13627. We have the wire. Now let's find the ground. All right, we are connected. So we're going to inject just 2 volts, just to start with. and see how much power we're grabbing. We're grabbing nothing, essentially. Yeah. Let's raise it to 5 volts. This will be safe up to like 14 volts. Yeah, we're grabbing 10 to 20, 10 to 30 milliamps. It's fluctuating. Now at this power, so it's like 5 to 10 milliwatts, right? So the thermal camera is not going to pick up anything at this power level. But why is it fluctuating is my question. So let's see if we can locate where does it connect. So since it's outputting probably 12 volts, it's gonna be definitely not IC705 because that's a throttle control, and 601 and 651. These are probably one of those two. They're also responsible for injectors and ignition and all that fun stuff. So most likely it'll be one of these. It is none of these. Not a single chip. Now it's definitely not gonna connect to the MCU, because that would make zero sense. But let's scrape through the pins over here just to be sure, but that would make zero sense. So what do we have here? So it's this port over here, it's this pin, but obviously it's going inside the board. Maybe there's a trace on the other side, but most likely it's somewhere inside the board. This transistor, if I remember correctly, is controlling the O2 sensor. I don't see any other transistors here. Well, these diodes are on the main power rail, so they're definitely, we're not going to be connecting here. Okay, we're connected to this resistor, and that's our 0.6. That's our 1.8K resistor, right? We get 0 over here, and we get 1.8K over here. So this is our ballast, right? That's what we're reading. That's why we're reading 1.8K in both directions, right? This is ground. So this is where we connect. And now, since I can't find this to be connecting anywhere else, right? Not a single chip is beeping. It would make sense. So this is our 1.8K resistor that we're seeing to ground. That's why we're reading in both directions the same. And it looks like this is not connecting anywhere at the moment, or at least not that I can find. It must be connecting to one of those chips, because these are our output stages, right? It's definitely not going to connect directly to the MCU, because no, that would not be the possibility. Typically, it's these two chips, but it's not. None of them beep. Now this one, it's also possible that we're connecting to this one, but this one is also not beeping anywhere. Nowhere. So it just seems like this pin is just hanging in the air. It just lost connection to where it was supposed to be connected. Now these are VVT motor controllers, so definitely it's not going to connect to these, but I'm going to check it anyway, just because I have no idea where to look. And nothing. It doesn't connect anywhere. Okay, let's see if anything suspicious around the via, like some burning or some deformation. Sometimes those vias seem a little like bloated, so you can tell that too much current went through there. I don't see anything here. Now the via looks kind of different than the other ones because I was poking the multimeter in there. So there's a little bit of conformal coding in there now. So that's why it looks different, but I don't see I don't see anything wrong with the via. So looks like this is the via, and we got 10K resistor over here. That's why I couldn't find anything. Okay, this is where we have to poke, because we had 10K resistor over here. That's why it's not beeping anywhere. Let's wire it up. But no shorting. I probably should have cleaned the conformal coating first, but it's just gonna burn off like this. And let's hook up the wire. A little bit of flux, and come out like this. Alright, it doesn't have to be perfect because we're not going to be pushing current through it. We just want to find the chip responsible. So now we should have 10K resistance over here, and we have beautiful 10K. Alright, so now we're going to find the chip. Well, the chip, since it's 10K, actually, it doesn't necessarily have to be an output stage, but most likely it will be. And it's this guy. There you go. And at 0, 0. So this via. Okay, so this is 970, SE 970. So let's remove the wire. There's gonna be a little blob over there, but that's fine. And what we're gonna do is we're gonna swap the SE 970 with from the donor. So here we have the exact same ECM, just with no VVT, right? So 703 and 704 are not populated, and we have fewer chips over here. But other than that, it's the same ECM. So obviously the chip is the same. This is output stage, so it's gonna be the same on all of these. And our 1.8K resistor is not populated on this one, but it should also connect the same way to this pin. Oh, it's open. It's open unless 10K is too much. Alright, because probably if it's not populated here, it's not going to be populated here either. Yeah. See, the resistor is missing here. Right. Alright, so we just have to do swapperoo and ship it back. I'll probably just grab the EEPROM from it, and if it doesn't fix the issue, I'll just clone it to the replacement. That's the best we can do if we can't figure out what's wrong. But we'll see. Maybe the chip swap will resolve the problem. But the question is, why did it stop working? And I have no answer, not even a suspicion. I have no idea why it would fault out the same way on the second ECM months after the replacement. There's gotta be something wrong with the car, you would think. What's the likelihood of getting the ECM with the same fault that just appeared? Unless it's a manufacturer defect or something like that. I mean, it's also possible, but I think we would have known by now, unless it's very unusual defect, right? All right, let's get the chip swap. Alrighty, the chip is replaced. It went pretty easy because I replaced the tip. With my old tip, it would have been a lot more difficult. Well, I got a lot of use out of this one, but yeah, that's the end of its life. Now, if this doesn't resolve the problem, that means the problem is in the MCU. In which case, all we can do is just clone it, because there's really no reason to replace the MCU. I mean, we could, that's not a problem, but if you replace the MCU, it's easier to just clone it. Unless you have like some specific map you want retrieved from your MCU, that unfortunately is not covered by the cloning. But you know, again, we would have to hook up to these terminals over here to read the flash, and then flash it to the replacement MCU. It's possible, but I don't have the pinout for these. I do know where to get it though. So I could do it if we really had to, but it's a lot of work, and it's essentially better to just clone it and tune it again, and that'll give you the same result. But we'll see. Hopefully this was an output stage issue, which means this repair will resolve it. If not, it's the MCU issue, and I don't know, we're gonna be following this case closely, because it's very unusual that it happened twice within like a year. So there's definitely something going on here, and it's either something on the car that is causing it, or it's a defect. In either case, we want to know. But that's all I got for you guys today. Hope you found this useful. Thank you very much for watching, and I shall see you guys in the next one.